In this presentation, we will see the use of don't care to reduce the function in a much minimum form. So if you are following my lectures, then definitely you have heard about this word don't care. We use this thing, or this thing appeared when we were in the codes, when I was telling you about the BCD code. Okay, so if you don't know, then you can see that lecture. But let's move to this example, and actually before moving to this example, let me explain a little bit about the don't care. So don't care is something, you can say, a state which is actually not mattered in a certain operation. For example, if you are giving a signal to an aircraft for its launch or for its landing, and only the hands are required, only you require your hands. For example, this is you, this is your hands, and this is your legs. Okay, and only these hands are required to give the signal to the aircraft. The position of your leg is of no use. Okay, they are not going to see your legs, so this thing is like don't care. You can put your legs any way you want to, but you cannot put your hands any way you want to, because you have to signal it. So your legs are like don't care. So we will see how to use this don't care along with this compulsory conditions, or the min terms, which is representing your function, to reduce your function to a much minimum form. Okay, so before wasting any time, let's see this example. In this, there is a 3 variable function f, which is having the min terms m2, m3, m4 and m5. Now this particular thing represents the don't care. Summation d, this d represents the don't care. Instead of d, you could have phi. Okay, this is sometime used instead of d, and 6, 7 is the cells in which we are having the don't cares. Okay, which means m6 and m7 are the don't care conditions. So let's first make our 8 cell K map. The 3 variables are a, b, c, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. Okay, so m2, m3, m4 and m5, let's fill it. 0, 1, 2, 3, 4, 5, and our 6 and 7 cell is the don't care. So we will write cross, or you can write D as well, but in most of the books you will find it cross, so I am using the cross notation for your don't care. So this is your K map, this is how it looks. Now we have to reduce it. So if you were not having this don't care, then what is the combination? So this was the first combination that you would have made in case you were don't having the don't cares. Then the other group, the other pair, you can say, is this one, and these 2 pairs can easily be minimized. But now you are having the don't care, so this don't care, this D, could be 1 or it could be 0 as well, as it is don't care. We can take it as 1, we can take it as 0, whatever we want to. But we take it as 1 in case we have to reduce our K map by using the min terms, and we take it as 0 in case we have to reduce our K map or reduce our function by using the max term. So keep this thing in your mind. This is when you are operating with min terms, and this is when you are operating with max term. Because what we want out of the K map, we want the greatest possible group of the ones which are 2, 4, 8, 16 and so on, and we want it to be the largest. We have learned already about the prime implicants. Okay, implicant is the group of 1, prime is the largest group of 1. So we want it the largest. So what if I change this cross with 1? So let's do it here. Let me make the another map for you. This is A, B, C. So this was your 1. I'm just writing this again in this map, but in this map I'm going to change this cross by 1. Why? Because this is the don't care and I can take it as 0 or 1. And now in this particular example I'm minimizing my function f by using the k-map, and in that k-map I'm using the minterms, and I have already explained you that in case of minterms we are going to take the don't care as 1. So I took the don't care as 1. Now let's do the pairing, or let's make the combinations or group of ones again. Now I'm not going to combine these two ones in this way like I did here, but I'm going to combine it like this way. Now it's not a pair, we have just made it a quad. Okay, the group of 4 ones. Similarly, I am not going to combine these two ones like this way, but I will do it in this way. So instead of having the pairs, the two pairs, I'm having the two quads. Okay, this is your quad 1, this is your quad 2, and as I have told you, when you do the pairing, when you are having the group of 2 ones, you eliminate the one variable. When you are having the group of 4 ones, you eliminate the 2 variable, and so on. So in this case you are having something like, from this you would have either AB, BC or CA in complemented or a normal form, but now you are having the only single literal odd with the other one. Let's see how. For example, first let me write the function from this k-map. In this we are having a bar, and the C is changing from 1 to 0, so C is neglected, and B is written as B because it is 1. Now or A, and B is 0, so it's changing from 0 to 1, so B bar. So A bar B or AB bar, this is actually your A XOR B. So you can see that this thing, and now I'm going to write the function from this k-map. So this is 0 1 0 0 0 1 1 1 1 0. So let's write it for the quad 1. In this A is changing, you can see this quad 1, in this A is changing from 0 to 1, but your B is not changing, it is 1, and C is changing from 1 to 0. So wow, we have just A reduced and also the C is eliminated. We just made A and C as 1, so we are left with B. Okay, if you don't know the basic of the k-map, then you may refer my earlier lectures on this k-map series, so don't get confused here. It's a very basic thing, we have actually moved on these things. So this don't care is actually the last part that you have to study in the k-map. So we are going to reduce this, write this quad 2. In this quad 2 you can see that B and C both are changing from 0 to 1, so they are 1, and A is 1 and it's not changing, so I will write it as A. So you can see that the same function can be written as A XOR B, which is A complement B or AB complement. In this you can see extra literal in every what you can say, in every ANDed operation, but here you are having A or B, only a single OR gate is required, but here AND gate is required, then another AND gate is required, and then OR gate is required. So 3 gates are required, but here only single 2 input OR gate is required. So this is the advantage of using the don't care as 1 in case of minterms grouping, and 0 in case of max term groupings. So I think it is now clear to you what the don't care is and how we have to use it. If you feel any problem, then please ask it in the comment box. I will try to make another video, another example with 4 variables if you have any doubt on it. So that's all for this presentation. See you in the next one.